Welcome back! This is going to be the second to last video in this series on making the Arbor support. As is usually the case, we've got to make something else first. We need to make a drawbar for this Cat 40 collet chuck. So let's get over to the lathe and get that made. And how about now? 565.5 there. More towards the middle, I'm getting 563. So okay, the micrometer likes it, so let's see what the collet chuck thinks. Collet chuck is happy. I'm ready to turn this piece, which will be the back of the drawbar, to 1 1/8. Right now it's 1.5 inches. I wish I didn't have to take all that much out, but I want to capitalize on this piece of scrap or a drop-off maybe from when I was making the Arbor sleeves. I think we're about there with the reaming. Yeah. That's about like 1/8 of an inch or so sticking up above the top of this part, so we'll drive it in here just like that. Now we're going to mill a 3/4 hex on the end of this. 3/4 because that's the same wrench size as the drawbar on the Bridgeport head, and on these clamps. It's simpler that way. So there's the completed drawbar, and I'm about 9/1000ths undersize of 3/4 on each of the hex flats, and that's fine for what this is going to have to perform. Funny thing is that now that this drawbar got finished, the collet chuck it's meant for finally got freed after I sprayed some WD-40 on it, but it's been locked up since I got it out of the box. Even with the wrench, it wouldn't unloosen. My coworkers and I moved the mill forward a little bit, so now I can get behind it, and now I can put the drawbar in as well. And that means the collet chuck can also go in. What I have here is a motor that I've put in place of the original motor because we don't have 3-phase right now. And this is how we're going to do the final boring that will be for the Arbor side. I know this motor works because I tested it after I wired it, but what we haven't seen yet is we haven't seen the motor driving the mill spindle. We're going to try that out now. It'll probably be the first time this mill spindle has turned under power in who knows how long. Look at that. Yeah. That works. So, I'm going to put a proper switch on this, or something approaching a proper switch. So now I can finally get this Bridgeport head off of the machine. I want to see what the RPM this mill will run at its slowest speed. I know that what's in the manual is not going to be correct since I've put a different pulley on the motor. So that's 300 RPM. We're now at a point in the machining of the Arbor sleeve that's going to determine the run out or lack of run out when an Arbor is installed in the machine. Essentially the accuracy of the whole part. And that is the machining of the bearing raceway. I've been trying to design the Arbor support as close to the original Nichols part as I could. The original being made of cast iron and likely made on a jig bore or some other high precision machine, I expect. Casting not being practicable in my case, I've made it out of round stock and stuff like that. But I tried to get the original bearings that were specified in this drawing of the machine. I was able to get one of them, but not the other. I am able to get the Torrington B912, this needle bearing, but the other bearing it calls for is a Boston Gear Works A09, and I called up Boston Gear Works. They are unable to identify this part or have any information on it. So what I was able to get is the smallest outer diameter thrust bearing I could find, which is just under an inch outer diameter. In any case, that situation requires me to have these two bearings in an orientation like this, and that means that I'll have to have a 1-inch bore right behind a 3/4 inch bore. What that means for me is I'm going to make a sleeve, and the needle bearing will go into a sleeve. That sleeve will go right in next to the thrust bearing. Here is the sleeve for the needle bearing so far. It's a piece of 12L14, which was a good choice, I think, because I could get it to a real polish. It's going to be shrunk fit into the Arbor sleeve. I've got the inner diameter semi-finished. It's around 700 thousandths. And what will happen is I'm going to part off my piece of it here, 2 pieces. Machine the Arbor sleeve in situ, with the part attached to the mill, and then heat and shrink fit the Arbor sleeve into the Arbor support, do the finish machining again on the machine with it attached. Remember this thing? It's getting its chance too in this project. It's not perfect, but it's probably the best I'm going to get. We are now finally in the setup for boring the Arbor sleeve. Overarm is loose in the overarm here, and it's clamped into the vise. There's the boring bar. There's the spacer from the welding jig to balance the jaw. So we are all ready to get started. But first, I'm going to go home because I'm done. Here's the other one, and we're going to do it better this time. We're going to be a little more cautious, I suppose. This one, I'm going to do it a little bit differently too. Instead of boring out all of that, I'm going to drill it to 15/16 first, and then bore it. And we'll drill it to a depth of 750. So now we're going to get started boring on the second one now. We've drilled it out to 15/16, and there's a big cone right at the end of the cut because it's there was a drill bit there, so the boring bar will have to chew through that. It's going fine so far. We'll see how it likes it when it gets to that included angle. I'm just about ready to shrink fit the needle bearing sleeve into the Arbor sleeve. The Arbor sleeve is bored to 992 and our needle bearing sleeve is 992 and a half of a thousandth to 993. So this is going to go in just fine. I better remember to put in the thrust washers and the thrust bearing first once I get it hot. Okay, going by the color, that should be plenty. There are the thrust bearing. Here's the needle bearing, and that just about dropped in all by itself. There it is. Hardly needed the press, but we had it just in case. Okay, this is going to cool off, and then the next step will be to bring it back to the milling machine, and we're going to bore the inside of this out to the final size for the needle bearing.